The remainder theorem in polynomials, it states that when a polynomial f of x, when it is divided by a linear polynomial x minus a, then the result of that division will leave a remainder that will be equal to f of a. Okay. So what is the real meaning of this statement or theorem? First we have to understand that, and then we will go into the proof or the details. All right. So if we were to define a very general form of a polynomial, we say that it is, let's say, Cn, and then there is x variable to the power n. Then you say Cn minus 1, then there is a variable power n minus 1. And you keep on going like this all the way until you reach a constant, and that is C0. Keep in mind that these terms containing Cn or Cn minus 1 or C0, all of these are constants. You can also call them as coefficients, right? And these exponents, they all are non-negative integers. All of these exponents, n minus 1, n minus 2, or n, or whatever it is, right? So this is a true polynomial in its very general form. Now when you divide this entire polynomial with a binomial, which is x minus a, so the result of this division will yield a remainder, and the value of that remainder can be found as by substituting value of x is equal to a in that polynomial, simply by substituting a in place of x. Okay, and you can say that this f of a, or the remainder, can be computed as Cn times a to the power n plus Cn minus 1 times a to the power n minus 1, and so on all the way until you have replaced the value x is equal to a in all of the terms of that polynomial. Okay, this is the meaning of this theorem. This is the purpose of this theorem, to find a quick value of the remainder of dividing one polynomial with a binomial. Okay, so let's take an example to understand this theorem a little better. All right, so my example is this, that there is a polynomial p of x which is equal to 4x squared plus x plus 1, and then there is another polynomial g of x which is x plus 1. We are dividing p of x with a polynomial g of x, and then using the long division method, find the remainder and also find the remainder using the remainder theorem. So there are two ways to find the remainder. Okay, so first let us find the remainder using the remainder theorem. Okay, in this case, what is my dividend, the polynomial? It is p of x, and that is 4x squared plus x plus 1, right? And what is your divisor? The divisor is g of x, and that is equal to x plus 1. The very first thing what we need to do is to convert this x plus 1, which is the divisor, into the form of x minus a. Okay, and the way you can convert that is you can simply rewrite the whole thing as x minus, and then you put a negative 1 inside the parenthesis. Okay, in that case you can simply say that your a is equal to negative 1, correct? All right, so now that you have the value of a which is equal to negative 1, you can simply substitute that value in this dividend, which is p of x, and then you can compute your remainder, right? So in that case I will say that p of negative 1 will be simply equal to 4 times negative 1 square plus negative 1 inside the parenthesis plus 1, right? Now these two negatives will cancel each other, right? And all you're left with is simply 4 times negative 1 square, which will be just 4. So this is your remainder, right? Now let us try to compute that can we obtain the same remainder using the long division method. Okay, so now let us apply the division method, the long division method of dividing one polynomial with another polynomial. Okay, so your dividend is 4x squared plus x plus 1, and then your divisor is x plus 1, right? And what do you do when you have to divide polynomials with another polynomial? You take one step at a time. That first you get rid of the very first term in the dividend, right? And you have 4x squared here. You want to find a multiple that you can multiply with x plus 1 so that the first term becomes 4x squared, and that will be 4x, because 4x times x plus 1 is equal to 4x squared plus 4x. You are applying the distributive law in this method, right? And then you obtain these two values. So we will just simply rewrite this whole thing here, 4x squared plus 4x. then you have subtraction going on, and you will obtain your remainder in step 1 to be, these two will cancel out, and negative 4x plus x will give you negative 3x, and then you get your 1 here, and then this becomes plus 1. Okay, in the second step, now you're trying to get rid of negative 3x. All you do is you simply multiply the x plus 1 with negative 3. You obtain negative 3x here, and then negative 3, because negative 3 times x plus 1 will give you negative 3x, negative 3. Once again, you are applying the distributive law, right? And then you solve this here, you subtract, this becomes plus, this becomes plus. These two values will cancel each other, and then 3 in positive, 1 in positive, together they will make it 4, right? So in this case, what is your quotient? The quotient is 4x minus 3. What is your divisor? The divisor is x plus 1, right? And what is your remainder? The remainder is 4, right? This is my remainder. And that is exactly the same remainder you found when you applied the remainder theorem, right? So the whole purpose of this exercise is that a remainder theorem, it will basically help you find quickly the remainder of division of one polynomial with another polynomial. Only thing is that remainder theorem is applicable only when the divisor is x minus a, meaning it is a binomial. Okay, so this is what is known as the remainder theorem, and this is how you prove it. So in this tutorial, not only you discussed about the concept of the remainder theorem, but you also learned about how to divide one polynomial with another polynomial, and we used the long division method. Okay, so this is where we pause today for the concept on remainder theorem.